Hi friends, today I explain you theory part of chapter 9. Our chapter 9 is some application of trigonometry. So in this chapter we have learned about some application of trigonometry. Now where we can use the trigonometry concept. If in right angle triangle we know one angle and one side of right angle triangle, then by using it we can find the other sides of right angle triangle by using the trigonometric ratios like sin theta, cos theta, tan theta, cosec theta, sec theta, cot theta. So in such a situation where one right angle triangle is formed, and if we know the one angle and one side of right angle triangle, then we can find the other sides of right angle triangle. So by using this concept, we can find the height of building, we can find the height of pole, we can find the height of street light, we can find the height of red house, we can find the range of red house even, we can find the distance between two boats in a sea, we can find the distance between two vehicles on a road, we can find the height of tree. So many applications are there. Okay, in many concepts we can use the trigonometry concept, but one condition is that one right angle triangle needs to be formed. Okay, so for that we assume that our building, street light, all these things we consider it a straight, means we consider it perpendicular with the earth. Okay, a building is there, we and that time we assume that this building AB makes 90 degree with the earth. If AB is a pole, then even we can assume that it is a perpendicular with the earth. For tree, red house, all these things we assume one thing, that is that object is perpendicular with the earth. If it is perpendicular with the earth, then at any other point it forms a right angle triangle. So if one right angle triangle is formed, then we can use the trigonometry concept. Now let's take one example. That means AB is a building. It is perpendicular with the earth, right? AB is building, it is perpendicular with earth. Now at point C, one person is standing. At point C, one person is standing. Now this person C, observe top of the building. Means this person at point C, observe this point A, that means top of the building. Okay. Now if we know this angle, for example take a 30 degree. If we know this angle 30 degree, and if we know the distance between the person C to the building, means a distance between B and C, if we know it, suppose a 30 meter, then we can find the height of building AB by using this angle 30 degree and this distance BC 30 meter. Okay, so in this case we can use the trigonometry concept. Sometimes the height of building is a very larger, at that time we cannot find the height of building by measurement. At that time we can use this concept, because right now advanced technology is there. So if we throw a laser light from any point to the at some height, then by instrument we can directly find the angles between horizontal and that ray of laser. So we know the angles, we know the distance between that object and that person. So alternately we can find the height of that building, otherwise red house, whatever thing is given. Okay, so in such type of situation we can use the trigonometry concept. Now in this situation, observer observes the object. Observer observes the object. Observer means a person who observe. And now whatever things observer observe, it is called object. Okay, so here two terms, observer and object. The line joined between observer and object, it is called line of sight. A line joined between object and observer, it is called line of sight. So I already written one definition here for line of sight. The line of sight is the line drawn from the eye of an observer to the point in the object viewed by the observer. Alternately, it means that line joined between object and observer. Now sometimes observer is one person, right? So if one person is there, at that time a person have its own height. We consider eye of an observer at a height which is equal to the height of person. Okay, so at that time if height of person is given, we considered it. But in such but sometimes a height of person is not given. At that time we ignore that height of person, because at compared to height of building, a height of person is very small. That's why in such a situation where the height of person is not given, at that time we neglect that height of person. But if height of person is given, at that time we considered it. Okay, now three cases possible for observer and object. First case, observer and object have same height with respect to earth. Observer and object have same height. At that time if we know the height of observer, that ultimately if I join this, then this becomes one rectangle. So alternately height of object and height of observer are same. So if we know the height of object, if we know the height of observer, then directly we can find the height of object if both are at same height from the earth. Second case, height of object is greater than the height of observer. Here observer and here object. If height of object is greater than the height of observer, in this situation the angles created between the horizontal and line of sight. Again line of sight, that means if I give AB, so AB is line of sight, line between observer and object. So this line AB makes whatever angle with the horizontal, it's called angle of elevation. It is called angle of elevation, because in this type of situation we need to raise our head, right? We need to raise our head. In this situation whatever angle is created with the horizontal, it is called angle of elevation. So here one definition is written for angle of elevation. The angle of elevation of the point view is the angle formed by the line of sight with the horizontal when the point being view is above the horizontal level. That means the case when we raise our head to look at the object. Now if a height of observer is given, now whatever, so we need to draw one horizontal line when eye of observer is here. Now from that, if now this is the horizontal level, right? If our object is above the horizontal level, that means we raise our head to see the object, and the angle created between this line of sight with the horizontal, it is called angle of elevation. Now in this example, means a building, here one person is standing at point C. This is the eye of an observer, so this is our horizontal level. Now building have height higher than the observer, so our object is here, so we need to raise our head in upward direction, right? So this is line of sight which is created angle with the horizontal, it is called angle of elevation. Okay, this is our angle of elevation. Now third case, in third case height of object is less than the height of observer. Height of object is less than the observer. In this type of situation, if we want to observe the object, then we need to lower our head, we need to see in downward direction. So in this type of situation, the angle created between this line of sight with the horizontal, it is called angle of depression. Okay, it is called angle of depression. Here height of object is less than the height of observer. Okay, now our observer is present here at some height with the earth. Okay, so we need to draw one horizontal level here which is passed through the eye of an observer, and if here one object is there, means object is present below the horizontal level. Object is present below the horizontal level. At that time, if we want to see the object, then we need to lower our head. In this type of situation, angle created between this horizontal and this line of sight, it is called angle theta. Is in this situation, angle theta is angle of depression. So for angle, it's a two things are there: angle of elevation and angle of depression. In elevation, object is present above the horizontal level, and in depression, object is present below the horizontal level. Second thing, if height of observer is higher than the height of object, means in angle of depression. Now if we draw one horizontal level here, now here two angle is possible, this one and this one, but we are forming right angle triangle here. Okay, we are forming right angle triangle, and in right angle triangle, one angle is 90 degree, so other angles needs to be acute angles, right? So in this situation, angle created between line of sight and the horizontal level, total two angles are present, but we need to consider this acute angle, because in right angle triangle other two angles are acute. So we need to consider acute angle. Okay, that's why we consider this angle. Angle created between line of sight and horizontal. Same thing in elevation, even we need to consider the acute angle. Okay, in angle of elevation, again total two angle possible, this and this, but we need to consider this acute angle. Okay, so in both the case we need to consider the acute angle. So in two cases, means angle of elevation and angle of depression. So in case of angle of elevation, our object is above the horizontal level, and in angle of depression, our object is below the horizontal level. Okay, so here one definition is given. Just read the definition. It is the angle of depression of a point on the object being viewed is the angle formed by the line of sight with the horizontal when the point is below the horizontal level. That means the case when we lower our head to look at the point being viewed. Okay, so object is present below the horizontal level. That means height of object is lower than the height of observer. So we need to lower our head. In this type of situation, angle created between horizontal level and object is called angle of depression. Here one example is there. Now this time observer is standing at the top of the building, and one object, means point C, it is on the earth. So observer needs to lower his head because the height of object is less than the height of observer. So in this type of situation, this is our line of sight, this is horizontal level, and this acute angle is called angle of depression. Here we are talking about angle, but we know the values of trigonometric ratio at some specific angle: 0, 30, 45, 60 and 90. But here no use of angle 0 and 30, because at angle 0 only horizontal line is there, it does not form the right angle triangle. At angle 90 degree it forms only vertical line, it does not form the right angle triangle. So we cannot use angle 0 and 90. So after that, three possibility are present: 30, 45 and 60. So in standard 10, our syllabus is limited up to these three values only, means 30, 45 and 60. In real life situation, the angle created between line of sight and horizontal, it can be any value. Okay, means it can be 12, 15, 75.5, but we can find the value of trigonometric ratio at that angle by using the scientific calci. Okay, in scientific calci we can find the value of trigonometric ratio at any angle, but right now in standard 10 we cannot use the scientific calci That's why our syllabus is limited up to this 3 value of angles, means 30, 45 and 60. Okay, other values is not given in standard 10. In further study, you can use this trigonometric concept for every angle by using the scientific calci. So here we need to remember the value of trigonometric ratios at this 3 angle, means 30, 60 and 45. Second thing, whenever we need to use the relation between hypotenuse and opposite side with respect to angle, on that time we can use two trigonometric ratio, that means sin theta and cosec theta. If we want to find relation between hypotenuse and adjacent side, at that time we can use cos theta and sec theta, because formula of sin theta is equal to opposite side upon hypotenuse, cosec theta is equal to hypotenuse upon opposite. Same thing, cos theta is equal to adjacent upon hypotenuse, sec theta is equal to hypotenuse upon adjacent. So cos theta gives the relation between adjacent side and hypotenuse. If we want to find relation between opposite side and adjacent side, at that time we can use tan theta and cot theta, because tan theta is equal to opposite side upon adjacent side and cot theta is equal to adjacent side upon opposite side. But in this chapter we are going for sin theta, cos theta and tan theta only, because a value of sin theta, cos theta, tan theta we can easily remember. That's why. Otherwise we can use the cosec theta, sec theta and cot theta, because whenever we remember that trigonometric values, first of all we need to remember value of sin theta, cos theta and tan theta, and by inversing it we can find the value of cosec theta, sec theta and cot theta. So we try to use sin theta, cos theta and tan theta only. So what are the values we need to remember for this chapter? For chapter 8, Introduction to Trigonometry, you need to remember all the table, but for application of trigonometry, we want value of sin theta, cos theta and tan theta at angle 30 degree, 45 degree and 60 degree. First of all, sin theta at 30 degree 1 by 2, then at 45 1 upon under 2 and at 60 under 3 by 2. How we can remember this? That I already explained you in theory part of Introduction to Trigonometry. Okay. Now reverse this 3 value, so we can get value of cos theta under 3 by 2, 1 upon under 2 and 1 by 2. Then for tan theta we need to divide sin theta by cos theta. So divide sin theta, so 1 by 2 divided by under root 3 by 2, it's a 1 upon under root 3. Here 1 and here under root 3. So we need to remember these values only for chapter 9. Okay, so here our theory part is done. If you have any doubt, then write down in comment section. I will give you answer in my next video. Okay, thank you.